Dear students, welcome to s.mathguru classes. So our main discussion is Euler's theorem, and this type of problem is most important for engineering courses. It may be in first semester, it may be second semester or third semester, whatever may be, but these are important for engineering courses and degree courses also, B.Sc, B.Com, we know this Euler's theorem. Now we consider Euler's theorem already defined and solution already given. Now let us consider deduction 1. Deduction from Euler's theorem. If z is a homogeneous function xy of degree n and z equal to fu, then x del u del x plus y del u del y equal to n f of u by f dash u. These are deduction 1. Now solution we consider. Here given z is a homogeneous function of xy of degree n. So since z is a homogeneous function of degree n, therefore by Euler's theorem we have, so what we have, x del z del x plus y del z del y equal to degree into function. We consider this is number 1. But here given z equal to given f of u, z equal to f of u. So if we differentiate partially with respect to x, what we get? Del x f of u, and this can be written as f dash u del x by using chain rule. And if we differentiating with respect to y partially, and we have this one f of u f dash u del y, we get this. So we putting this value in this equation number 1, what we get? Now 1 implies we putting this del u del z del x del z del y in this equation 1 implies we get x del z del x we get this one f dash u del x plus y del z del y, this value is f dash u del y. On right hand side n z means f of u, we putting f of u. Now we dividing both side by f dash u, this f dash u dividing both side by f dash u, then we get x del u del x plus y del u del y equal to n f u by f dash u. We dividing both by f dash u, then we get n f u by f dash u. These are proof. This one x del u del x, y del u del y equal to n f u by f dash u. This is deduction 1. Euler's theorem deduction 1. So this is our proof. We get this our proof. Now next you consider this problem, Euler's theorem deduction 2. Deduction 2, prove that x del square u del x square plus 2xy del square u del x del y square plus y square del square u del y square equal to g dash u minus 1, where gu equal to n f u by f dash u. We have to prove this equal to this. Now solution we consider by Euler's deduction formula. Formula 1, we have what we have: x del u del x plus y del u del y equal to n f of u by f dash u. This is our deduction formula 1. This implies x del u del x y del u del y equal to gu, because gu means this one. This is gu, where gu equal to n f of u by f dash u. This one given. Now we want to prove this. So in our proof we have del square u del x square. Then we differentiate with respect to x. If we differentiate with respect to x, we get this one. So this is number 1. We consider differentiating both sides of 1 with respect to x partially. We get what we get. If we differentiate with respect to x partially, we get del x x del u del x plus y del x del u del y. We are taking y outside because we differentiate partially with respect to x. At that time y is constant. So this is del x g of u. And this is product of two functions. First function del x of second plus second function del x of first, and this one remains same. We consider x means first function, this is second function. First function del x of second function del x of x, and this is y del square u del x del y. This is, if we write directly, g dash u del x, we get this one. Now this implies x del square u del x square, we get this, and this is del u del x, this one 1, y del square u del x del y equal to g dash u del x, we get this one. And this del u del x taking on right hand side, we get x del square u del x square, y del square u del x del y, g dash u del x minus del u del x, we get this one. So just taking this one on right hand side, we get this. Now next we get, this implies x del square u del x square, y del square u del x del y, and from these two del u del x common, we get g dash u minus 1 del u del x. But in our answer we have del square u del x square multiplying by x. So we are multiplying both sides by x. If we multiplying both sides by x, therefore we get x square del square u del x square xy del square u del x del y. So this is g dash u minus 1 x del u del x. This is number 2 we consider. Number 2. Just multiplying both sides by x, we get this one. So again, we differentiate this number 1 with respect to y, because in your problem del square u del y square we have also. So if we differentiate with respect to y, then we get this one. Again differentiating 1 with respect to y partially, we get. So what we get here, x is constant, we get del y del u del x plus del y del u del y, and on right hand side del y g of u we get, and this will be x del square u del y del x. This is product of two function, y del y del u del y del u del y del y del y, and this will be g dash u del u del y. We get this. This implies x del square u del y del x, y del square u del y square this, and del u del y into 1 g dash u del u del y. So this implies x del square u del y del x, y del square u del y square, and this one taking on right hand side g dash u del u del y minus del u del y, taking right hand side we get minus. Now this implies x del square u del y del x, y del square u del y square, and taking del u del y common, we get del u del y. We get this, and multiplying both sides by y, because in our solution we have y square also. If we multiplying by y, then you get y square. Now therefore if we multiplying by y, then we get xy del square u del y del x, and this is y square del square u del y square. This is g dash u minus 1 y del u del y, and this is number 3 we consider. 3 number. Then adding these 2 and 3, now 2 plus 3 implies 2 plus 3 implies, in 2 we get this one x square del square u del x square plus xy del square u del x del y, and here 3 xy del square u del y del x, y square del square u del y square. On right hand side this one and this one we get g dash u minus 1 x del u del x plus g dash u minus 1 y del u del y. We get this one. So this implies x square del square u del x square. This and this 2xy del square u del x del y. This is y square del square u del y square, and from these two g dash u minus 1 common, we get x del u del x plus y del u del y, and x del u del x, y del u del y means gu. So we get this will be g dash u minus 1, this is gu using 1. So using 1. So finally we get, therefore finally we get x square del square u del x square 2xy del square u del x del y, y square del square u del y square equal to g of u g dash u minus 1, and this is the proof. We get our proof. Hence proof. This is the proof. Very easy, very nice. Let us consider one problem. If u equal to log of x square plus y square by root x plus root y, find the value of x del u del x plus y del u del y. And number 2, x square del square u del x square 2xy del square u del x del y plus y square del square u del y square. Before solving this problem, first we have to know what is the degree of the function. Solution start. So u equal to given log of x square plus y square by root x plus root y. Now log means here base is e. E is silent, e not given. So this implies if we remove this log, then e to the power u equal to x square plus y square by root x plus root y. We get this. Now this implies e to the power u equal to, taking x square common, 1 plus y square by x square, taking root x common, 1 plus root y by root x, this equal to x square 1 plus y square by x square by root x means x to the power half 1 plus root y by root x. We get this, and this half becomes in numerator. If it becomes in numerator, we know this formula from lower class, a to the power m by a to the power n. This is a to the power m minus n. Then here x square by x to the power half, then x to the power 2 minus half, this is 2 LCM 4 minus 1, x to the power 3 by 2. So if we calculate this, we get x to the power 3 by 2. This is x to the power 3 by 2, 1 plus y square by x square, 1 plus root y by root x. We can write this is x to the power 3 by 2 phi of y by x. The definition of homogeneous function, it was given in first video. This can be written as this y by x form, we write y by x. So what we get, finally we get e to the power u equal to x to the power 3 by 2 phi of y by x. So this is, therefore e to the power u is a homogeneous function of degree 3 by 2. Therefore e to the power u is a homogeneous function of degree 3 by 2. So we get this one. So by Euler's deduction formula, formula 1, we have. So what we have? Euler's deduction formula 1 we have. So we have x del u del x plus y del u del y equal to n f of u f dash u. These are deduction formula. And f of u means this is e to the power u. Here e to the power f of u means e to the power u. Then f dash u, this is also e to the power u. So we get x del u del x plus y del u del y, and n means degree. Degree means 3 by 2, and this is e to the power u, e to the power u. This implies x del u del x plus y del u del y equal to 3 by 2. First answer we get. We get the first answer. So we get this. Again, you know, since GU equal to n f of u f dash u. So n f of u f dash u, this is n means 3 by 2, and f of u e to the power u, this is e to the power u, this is 3 by 2. This we get GU equal to, we get this one. So what we get, therefore this is, we know GU, therefore GU we get 3 by 2. G dash u, if we differentiate, this is constant function, this will be 0. By Euler's deduction formula, we have, what we have, x square del square u del x square 2xy del square u del x del y plus y square del square u del y square equal to gu within bracket g dash u minus 1. This is our deduction formula 2. This one 2. So this implies x square del square u del x square 2xy del square u del x del y plus y square del square u del y square equal to gu. Gu means 3 by 2, g dash u is 0. Here putting 3 by 2, and this is 0 minus 1. This will be minus 3 by 2. So finally we get, what we get, x square del square u del x square 2xy del square u del x del y plus y square del square u del y square equal to minus 3 by 2, and this is our answer. Now our requirement is this value and this value. First value we get 3 by 2, and the second value we get minus 3 by 2. These are the answer. These are most important for any engineering courses. So this type of problem 100% sure will come. If Euler's theorem in your syllabus, this type of problem will come. Whether this will come or others will come, but this type of problem 100% sure will come. So dear students, I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.